Hi everyone! Over the last couple of videos, we implemented a few methods on the I/O trait. The goal was to provide a convenient API for reading and writing messages to the console and handling errors gracefully. I think it's fair to say that it was a success. At the end, the code of user creation service is quite clear and easy to understand. However, we can't say the same thing about the code inside I/O. It works and it's well tested, but there are a few subtle points to note. For example, it was quite tricky to figure out when to call unsafe run. Sometimes we did it too early, which broke the laziness of I/O, and sometimes we forgot to call it on internal actions, which means that some of the code wasn't executed. So, in other words, unsafe run is a very low-level API which can easily be misused. So it would be great to reduce the usage of unsafe run inside I/O as much as possible. Today we're going to go through the I/O methods one by one, and if possible, we'll try to find ways to re-implement them without unsafe run. This cleanup process is not mandatory, but it will help us to become more familiar with the I/O API, and we'll also implement new useful combinators along the way. Cool, so let's start at the top of the I/O trait. The first method is and-then. So and-then is currently used unsafe run on two internal actions. So please pause the video and try to refactor and-then so that it doesn't use unsafe run. This means that you will need to implement and-then in terms of other methods of the I/O API. Okay, so and-then run two actions sequentially. So we could potentially use the for comprehension syntax to do this instead. So we could replace the I/O constructor by for, add a yield keyword at the end, we remove unsafe run here and here, and basically here we need to put left arrows. So this, the current action returns the result, but we want to discard it. So now we need to be explicit about it with the for comprehension syntax. And other return the result that we want, so let's call it result, and this is what we yield at the end. So as you can see with the for comprehension, we say, I want to run the current action, this, then I want to run the other action, and then this will give me eventually a result, and I yield the result at the end. So it's a bit more verbose, but at least we don't use unsafe run anymore. Another way I kind of prefer to use the for comprehension syntax outside of the I/O trait. Within the I/O trait, I would rather use explicitly like flat map instead. So what we could do is say flat map. Flat map gives us the result of the current action, so this will be an A, but we want to discard it, so we can just say underscore. And then we run the second action, other. So it's really up to you which syntax do you prefer. Eventually it does almost the same thing. Personally, this is my favorite one. So let's run the test just to see if we haven't broken anything. So let's run the test. Yeah, all good. Next, let's have a look at map and flat map. So these two methods are really similar. They both take a callback function and returns an I/O of next. The only difference is that the callback of map is an FP function, while the callback of flat map lets us perform actions. So in your opinion, can we implement map in terms of flat map or the other way around? So I will let you try both possibilities. Please pause the video and give it a try. Okay, so let's give it a try. Let's first try to implement map in terms of flat map, and then we'll try the other way around. So here, if we call flat map, this gives us access to a value. This value is of type A, so we can call callback with this value. And as you can see, IntelliJ tells me that now this is a value of type next, but in order to use flat map, we need an I/O of next. Now, this is quite easy to transform any value, like if you have an int and if you want to transform it into an I/O of int, you can always use the I/O constructor. It always works. What it does is that it just creates a new I/O that will always return the same result. That's fine. That may not be as efficient, but that's fine. Okay, let's run the test to see if we haven't broken anything. Yeah, all good. Okay, so let's roll it back. And now let's try it the other way around. Let's say that now we want to implement a flat map in terms of map. So if we do this, this will give access to value. We use a callback on this. Now, IntelliJ tells us that we have an IO of next while we need a next. So we could potentially run the call unsafe run on this IO and it will compile. And I'm pretty sure that if we run the test, it will still work. But we are kind of breaking the specification of map. Map is expected to be used only with FP functions, so only with functions that are deterministic, who can't fail, and who don't perform actions. But here, we do perform an action. We unsafe run an IO. So at the moment, it doesn't break our test, and it's probably fine with this current implementation. But we break the specification. And anyway, the goal of this kind of refactoring is to reduce the number of unsafe run in our implementation, and we don't really do that here. So I would rather roll it back and come back to this where flat map is implemented using the IO constructor and unsafe run, and map is implemented in terms of flat map. I think it's much better this way. Cool, so now let's move on to the next method, on error. So this method is much more difficult to refactor. The key is to notice that we call unsafe run twice, one on the current action and one on the cleanup function. So potentially we could use flat map to combine these two actions together. Let's try it out. So if we say flat map here, this gives us access to value, which is an A because we are within an IO of A. But this means that the callback function is only invoked if the current action is a success. Another way to say this is that flat map concentrates on the happy path, which is not good in this particular case, because we need on error to differentiate based on the status of the current action. If it is a success, then we keep the result, but if it is a failure, we must call the cleanup function. So let's try to implement another method on the IO trait that will tell us if the current IO is a success or a failure. You can find it a few lines below. It's called attempt. So attempt transforms an IO of A into an IO of try of A. This means that if the original IO returns a value, a normal value, we get back an IO of success. But if the original IO throws an exception, we get back an IO of failure. So let's pause the video and let's try to implement attempt. Note that it is completely fine to use unsafe run in the implementation of this method. Okay, so to implement attempt, we need to create a new IO, so we use the IO constructor, and then we need to run it and figure it out if it throws an exception or not. So we'll use unsafe run, and we need to wrap this call of unsafe run within a try. And that's it. Let's go to the IO test. You will see at the bottom of IO test, I wrote two tests for attempt. So let's run them, and let's check what they do. So the first test verify if, okay, so they all pass. So the first test verify if the current IO is a success. So for example, if it just increment a counter, it just return unit, and we call .attempt on it, we verify that the action is still lazy, nothing has been evaluated. And then after we run the action, counter is incremented, and it is a success because there was no exception. Now for the failure case, we do the same thing, except that now we do throw an exception, and we verify that after we call unsafe run, the counter is incremented and the failure has been thrown. So now the result is a failure with this particular exception. Cool. Okay, so now that we have attempt, let's go back to on error, and let's try to refactor it using a combination of attempt and flat map. So please pause the video and give it a try. Okay, so let's give it a try. First, we'll comment out this code. And the first thing we want to do is to figure out, is the current action a failure or a success? So we'll use attempt for this. Attempt gives us back an IO of try of A. Now we want to differentiate based on the value of this try. So we need to go inside the IO if you want. In order to do this, we'll use flat map. So flat map will give us access to the value of this try. and we can pattern match on this. If it is a success, then we don't want to do anything, we just want to keep the result, so we'll return value. Now, as you can see, IntelliJ tells me that it's not correct. Because we use flat map, now we need to return an IO of A in this particular branch. So we need to wrap a value with an IO. This is because the second branch, the failure, is going to return an IO as well. It's going to execute the cleanup function. So we need to do actions on both branches of the pattern match. Now here, what do we want to do? We want to call the cleanup function. This gives us an IO of other, but we don't care about it. Other, we're going to discard it. And then we want to rethrow the original error. So we want to rethrow this exception. So we're going to use the IO constructor, and inside of this, we'll throw the exception. So here, if you want, first we execute the cleanup function, and then we create an IO that will always throw an exception. Cool. So I don't know if you noticed, but in the companion object of IO, there is a method fail. And fail does exactly what we just did. So it's a method that takes an error and returns an IO of any type. So if you want, it's a wildcard that will always throw an exception. So we could very well do what we did, like this, do an IO throw exception. But I prefer to give it a name and say IO fail with the exception. Throw is always dangerous, so it's much better to reduce, it's a bit like unsafe run. We want to reduce this keyword as much as we can. Okay, so now if we want, we can make it even like, so people like it or not, but I think in this case it may make sense to make it a single letter variable, so like this, the meaningful code is more obvious. So here if you look at this, we say, okay, first we want to attempt to run the IO. Based on the status, if it is a success or a failure, if it's a success, we keep it. If it is a failure, we clean up we call the cleanup function, and then we fail. So I think it's quite nice to read this way. If you really want to save even more characters, you can use these ice cream operators. But as I said before, I think and then is, I'd rather use and then if you're not especially familiar with the IO API. You might find the end result a little bit cryptic. It certainly takes some time to get used to the IO API, such as attempt, flat map, and then, and fail. However, it is a worthwhile investment because we deal with actions on a daily basis. So it's extremely useful to have a concise and standard vocabulary to combine actions together. Additionally, the source code of IO libraries, such as Ch05, Monix, or Zio, are written in this style. So it's very convenient to be able to read code like this. Finally, let's look at the last method, retry. So now we should have all the building blocks required to refactor retry without using unsafe run. Similarly to onError, it's likely that we'll need to use a combination of flat map and attempt in order to achieve that. So please pause the video and give it a shot. Okay, so let's give it a try. First, let's comment this code. So we want to do something in case max attempt is lower than or equal to 0. So we can say if max attempt is lower than or equal to 0, then we want to create an IO that will always fail with this particular exception. So we'll say, for example, a new illegal argument exception like this. Okay, then we have the rest of the IO, so the interesting case is here we want to figure out, is the current action a failure or a success? So we have done it before, we need to use attempt for this, and then we need to use flat map in order to differentiate on the two possibilities. If it is a success, then it's actually the same as before. If it is a success, we want to keep the value and don't retry it, we are fine. Now the interesting bit is a failure case. So if it is a failure, what we did before, we did this if max attempt equal to 1, we want to throw an exception. So here we replace it by io.fail. And otherwise, we want to retry the IO. So we want to say call our function recursively. So now the good thing with attempt and flat map is that now we don't need to call unsafe run on retry. It's kind of the flat map who is in charge of composing the IOs together. First we attempt to run it, and then we retry it if needed. Okay, so let's run the code to see if it works. Yes, it does. Okay, so it's not necessarily more readable, but at least we don't have any unsafe run anymore. Now, one refactoring I would like to do before we move on is the fact that we have some logic about max attempt at the top and some logic about max attempt toward the middle. It will be much nicer if we could say else if max attempt equal to 1 here. So basically if we could move on this piece of code from here to there. Because if we do this, then the code of the recursive case is much simpler. If you want here, we already have 3 cases. Either max attempt is wrong, and then we want to throw an exception, or max attempt is equal to 1, this is the end of the recursion, or this is a default case of the recursion where we want to try to figure out is it a success or a failure. If it is a success, we keep it. If it is a failure, we retry it. And now we don't need to care about the failure anymore. So this means that this code is much clearer this way. Now, the tricky bit is to figure out what should we do if max attempt is equal to 1. So if max attempt is equal to 1, we need to create an IO that basically run the current one and doesn't do anything with the exception. So in fact, if you think about it, what we want is this. We want to have, if max attempt is equal to 1, it's a no operation. We just run the current action and we don't do any retry logic. So it's exactly this, the current object. Let's run the code. Let's run the test. Yes, all pass. So you probably find this code a bit weird the first time you see it, but it kind of makes sense to say that if max attempt is equal to 1, basically it's a no operation, so we just return the current object unchanged. So here we already have the guarantee that it is a no operation in this case, because we don't even touch the object, we return the same one. So it may take some time to get used to it, but eventually it will make sense, I guarantee you. Now, you may have noticed some similarity between retry and onErr. If you look at these two methods, maybe let's remove these commands to make it more clear. So if you look at these two methods, they both call attempt and flat map, and then if it is a success, they do nothing. If it is a failure, they do something. So really the only difference between onErr and retry, at least in the recursive case, is what they do in case of a failure. So maybe what we could do is to write a higher order function that captures this pattern, and then we'll use it to refactor onErr and retry. So this will be the last method we implement today. It's called handle error with. So if you want handle error with, the idea is that if the current IO is a success, we do nothing. But if it is a failure, we call the callback function and we keep the result of the callback function. So in a sense, it's almost like a flat map, but for the failure case. Flat map normally takes the success and gives you what to do next. Here it takes the failure of the original action and tell you what to do next in this case. Which could be useful, for example, imagine if you try to do some kind of action like closing the account of a user, this may fail. So you say, okay, if it fails, then you have an exception. You want to log the error and then, for example, send them an email to say, okay, something went wrong. So it's a way to perform some action in case something goes wrong, but if it is a success, you keep it. Now you may have noticed that normally flat maps takes an other, so it changes the return type. Here we can't, because in case if it is a success, we keep the result, so we don't really have choice. We need to return an IO of A also inside of this callback function. Okay, so please pause the video and try to implement handle error with. Once you're done, try to refactor the code of retry and onErr using handle error with. Okay, so handle error with, what we want to do is that we want to try to run the current action, so it may fail, so that's why we use attempt. Then we want to flat map it to see what's inside. We do an exhaustive pattern match, exactly like before. If it is a success, we keep the value. And if it is a failure, we want to call the callback. So if the code looks really similar, this is exactly because we are trying to capture a pattern from the previous method. So that's why we want to write this code once and for all and be done with it. Now let's enable the test inside of IOTest just to see if they work. Yes, it does. For example, you can see at this test, what it does is that it says, first let's bump counter by 1 and then let's return a constant a. Then let's multiply the counter by 2 and return a constant b. And we say, okay, if the first one, we say first, handle error with second, we verify that handle error with is lazy, nothing happened when you run it, before you run it. Once you run it, you get back a, the result of the first one, because it was a success. And counter is equal to 1 because we verify that the second action hasn't been executed. While on this branch of the test, what we say is that first we want to increment the counter by 1 and then throw an exception. And here we multiply the counter by 2. So here what happened is that once we run it, we verify that counter is equal to 2. Now, I didn't verify that we get back a result. This is because if it had thrown an exception, so the only two branches of this test are first and second. So if it had returned the result of first, it would have thrown an exception, and the test would have failed. So I don't even need to verify this. Okay, now that we have handle error with, let's try to use it in the code of on error and retry. So handle error with says, okay, if I have a failure, I want to do the cleanup function and then fail. So this is, again, this is an example where maybe the ice cream operator starts to make sense because we have something very concise. And this really says, okay, on error says if the current actions succeed, we do nothing. But if it fails, we want to do the cleanup and then we want to fail. So it's, you need to learn about these methods. It takes some time, but then it's extremely expressive. And what about retry? We want to say, okay, in case an error occurs, we want to basically call ourselves. And we don't care about the error because anyway, the error is handled here. So that's it, really. So now if you look at the code of retry at the end, it says that there is really 3 branches. If max attempt is lower than 0, we throw an exception. If max attempt is equal to 1, we end the recursion, we keep the current IO. And if it is bigger than 1, we try to run it, and if it fails, we call ourselves. And let's run the test. They all pass. In summary, today we saw that it is possible to drastically reduce the number of methods that use unsafe run. At the end, we only needed 2. Flat map, which is used for composing actions sequentially, and attempt, which is used for figuring out if an action is successful or not. So flat map is a glue used to combine IOs together, while attempt is needed to build all sorts of error handling combinators. I found that there is a certain beauty in implementing the entire IO API in terms of a very small numbers of primitives. But it's also very useful because unsafe run is dangerous. So the less we use it, the more confident we are in our code. And also the less tests we have to write because we don't have to be worried about breaking the laziness anymore. Cool, so that's it for today. I hope you enjoyed this session, and if you're extra motivated, you can find some bonus exercises at the bottom of user creation service, here. In particular, you will find that on error and retry have a bug, or at least an edge case that we haven't considered. Try to see if you can find it on your own. See you soon.